Hi, good morning. So welcome to the ZP Developer Zone. Obviously, every week we do a live streaming, and it's exclusive just to our ZP Developer Zone members. So I do appreciate it. I think with you guys, with many of you in Southeast Asia now, it's probably about 3 p.m. And for us in London, it's 8 a.m. So welcome. All right, so I'm going to dive straight into it because I know that some of you have a hard stop at 1:30. So I'm just going to do a quick summary of the ZP Developer Zone. I'm going to do a quick summary of ZP Developer Zone news. I'll do technical, and then I'll just summarize what we've discussed today. So I show this slide every week, so welcome to the ZP Developer Zone. We do have the Discord server. I'm often on it. Contact me if you want to say hello. We do offer discounts, exclusive discounts to our ZP Developer Zone members. I'm really hopeful now that there's a lot of vaccines coming for the COVID-19. I think there's at least about 3 that are kind of fairly imminent. So I'm really hoping that that will give us an opportunity to have a webinar together, a workshop together in Jakarta. I was a bit concerned that, we might not be able to do that next in 2021. Well, maybe we will be able to do it in 2021 in Jakarta. So let's watch that. I did announce it last week, but there is a PhD available in Norway. So please please sort of tell the other members that that's there. I also wanted, we also do collaboration. So I just wanted to kind of highlight a collaboration that we have with one of our members, and he was talking at I think it was a Chinese led conference on environmental pollution and environmental sensors. So he was talking about the development of an electrochemical sensor for polyaromatic hydrocarbons in environmental samples. And when I did a talk a few weeks ago about molecular imprinted polymers, that was the kind of paper I touched upon there. But yeah, we were happy to support Hasim in his presentation at that conference. So well done, Hasim, for presenting there. So the ZP Developer Zone is leading to, collaborations and people being able to then talk at conferences on the work that they're doing with ZP. So thank you, Hasim, for that. Just a little bit of news, like I say, that Hasim was speaking at that conference. It happened on the 21st of November. It was online because obviously of the current COVID-19 restrictions, but we were delighted to kind of sponsor Hasim for that. Another small thing, and I think I'm very interested and excited by this. Trypanosoma Evansi is something I first heard about when I visited Indonesia, I think in 2019. And April told me about it then. And this is now sort of warming up now for us. This collaboration has been going on quietly. April is starting to lead an international team on this. And, we're going to make a submission to the Bill and Melinda Gates Foundation. And I want to kind of say that I think the Bill and Melinda Gates Foundation is actually quite interested in supporting R&D in Southeast Asia, and they're interested in supporting local science in Asia. So I would actually encourage more of you to kind of follow the progress of Abril, myself, and Hasim, and the team that Abril is leading and we're supporting. Follow our progress, because if we work out, that we can find funding for this, then maybe many others of you can also follow that model as well. Yeah, so I can just see Hasim has joined in online. So thank you, Hasim, for coming online. So for those who are just kind of coming online now, I've just touched on a bit of news with Hasim talking about polyaromatic hydrocarbons at a Chinese conference, and I've also just touched upon the fact that we did have our meeting about Trypanosoma Evansi. There was a very interesting comment from one of the French collaborators, and he said, "Hi, Dima. And he said, look, we should apply to the Bill and Gates Foundation. And I would say, let me report back on our progress on this, because if it's successful, and I think it's going to be a very interesting model for many more of you. In the end, the Bill and Gates Foundation's kind of motivation is to do good in the world and to improve human health. And so much of what we do and talk about in these in these webinars is actually about improving. Hey, cool. And April's here as well. So April, I was just saying to people that I'd like them to watch our progress on the Bill and Melinda Gates Foundations. Let them watch our progress. If we're successful, and maybe we can help other people to be successful on this as well. So I'm just touching upon that. And April, as you are watching online, if you need me to write some stuff for that, I'm happy to do it. I think it's important that when we're applying for Bill and Melinda Gates Foundation, let's say support, it has to be led from places like Indonesia, because they want to support the local scientific effort in these countries. But it doesn't mean that people like ZP can't help with the writing or letters of support as well. Right. So I will just, now we're going to do a technical discussion. I like this technical discussion because it kind of reinforces some of the themes that we make quite a bit. So I talk about ELISA, I talk about protein detection, I talk about antibodies, I talk about antigens quite a bit. And so now I put together a bit of an animation about this, just to reinforce that a lot of what we do in our labs is exactly the kind of workflow that I'm about to describe here. But this workflow can be translated into so many sensors. So let me just go through the workflow. First of all, this is a paper. I am a co-author on the paper, so I'm sort of quoting some of the work I've been involved in. Now, HCG, which is the protein that we're discussing here. So we're going to discuss the electrochemical detection of HCG on a biosensor. Now, HCG is the basically the biomarker for sort of pregnancy. So if somebody does a pregnancy test and they get the blue line and it sort of confirms that they're pregnant, then it's really HCG that they're detecting. So what we're going to do, so the reason we use HCG in this paper is because it's actually quite readily available. The assay is quite robust. So it's really a model compound for doing antibody protein detection. That's why it's HCG. So the first thing that that happens in this paper is we take basically a screen printed electrode. So every week we talk about screen printed electrode. We take the screen printed electrode. So that's I represent it here with this kind of black rectangle here, and then we characterize it by cyclovoltammetry. So in cyclovoltammetry, I didn't label up the axes, but as you know, we sweep the voltage, and as we sweep the voltage, the current responds. And we sweep voltage and the current responds. The first thing we do is we characterize the electrode so that we know what the state of the electrode is. But what we're aiming to do is we're actually aiming to turn this electrode, which is just an electrode, into a sensor. And the difference between an electrode and a sensor is almost this sort of specificity and the selectivity that we can instill upon that electrode. So how are we going to instill the specificity? What we're going to want to do is we're going to want to couple an antibody to HCG onto the surface of the electrode. So the first thing we're going to do is put down a coupling reagent. Now in this case, the coupling reagent has a pyrene ring here. And pyrene is basically sort of 4 aromatic rings that are really good at sticking. I'm sorry, probably on the YouTube, my video is slightly blocking you. I apologize for that. But what we're doing is we're sticking a coupling reagent to the surface of the electrode. So it's really quite straightforward because you have a carbon electrode, you pipette on this coupling reagent, and now the electrode is activated towards being able to couple or covalently bond other molecules to the surface. So we do the first activation of the electrode, and then we do a cyclovoltammogram to see that we've altered the electrode. So in some ways, if you're following the paper, then you can know that you'll be successful by just following the steps. Now, the next stage that we want to do is, now that we're ready, we cannot see covered your camera. My camera's in the way, and I'm sorry about that. What I'm going to do actually is I'm going to just slightly come out of the presentation mode, just slightly, and actually move this in a little bit, shift this like this, and go back. So let me just, Hasim was just complaining online that my camera was covering up. Of course, I want to make sure you guys can see this. So we take the electrode. We do want to couple an antibody to the surface. So we take the electrodes, we characterize the surface using electrochemistry. Now we want to take this molecule, which is the orange circle represents a coupling agent, and the 4 black hexagons represent pyrene. And pyrene is really good at sticking to carbon surfaces. And then we're left with this coupling reagent, which is the orange circle. And there we are. And then that will stick to the surface. So we've functionalized the surface, so it's ready to now be coupled to. The next thing we're going to do is characterize the surface. Now we're going to take the antibody to HCG, and we're going to apply that. We're going to apply that to the surface. So now we generally have gone from an electrode to a sensor because this electrode has been given specificity. But I want to increase the selectivity of this electrode. And so I'm going to use a protein called BSA, bovine serum albumin. It's used a lot in biology and biochemistry and molecular biology, and we use it quite a bit in biosensors as well. And the BSA is then applied to the surface, and what it's doing is it's blocking the surface, and it helps prevent non-specific binding, because proteins, so HCG, we want it to bind only to the antibody, but most proteins are actually really good at binding to the antibody, and they're really good at binding to the surface. We want to block that surface, and one way of doing it is to block the surface with bovine serum albumin. So what I've described here is a process where we take the screen printed electrode, we pipette on a coupling reagent, the pyrene sticks to the carbon, and the coupling reagent then is left ready to be reacted. We pipette on the antibody then sticks or binds to the coupling agent, and then we block the surface at the end with BSA, bovine serum albumin. And then we characterize it again by cyclovoltammetry. And what happens is, when you've kind of altered the surface, because the cyclovoltammetry becomes what we call distorted. Rather than having these beautiful sharp peaks, the peaks move to a higher oxidation potential, and the current often drops. And that's an indication that we are increasing the resistance at the electrodes. And it sort of digs into, in some ways, we've had whole webinars on impedance spectroscopy, where we kind of say that you can increase the resistance at an electrode. And what we've effectively done is every time you put these kind of macromolecules on the surface of an electrode, you increase its resistance. So now, rather than having nice high peaks and nice lots of currents, we get the peaks have shifted because the resistance has increased, and the current is reduced because the resistance has increased. So we are characterizing this sensor as we go along. So the next slide is, we've taken the screen printed electrode, and effectively in the previous slide, we've turned it into a biosensor. Now, last week we talked about molecular imprinted polymers, but it was a very similar process. We took an electrode and we electropolymerized in the presence of a template, and we formed pockets and pores that gave it specificity. So this week, we've almost done the same thing, that we've taken an electrode and we've given it specificity by binding an antibody to the surface. But now we need to come to the testing stage. And so we're going to test it. We're going to take out our electrode, and we're going to put in, so these two axes, this is voltage and this is current. We're going to do a technique called differential pulse voltammetry. So into the solution, we put ferricyanide, and the ferricyanide can reach the surface of the electrode and give us a signal. Now, the technique we use in the paper was called differential pulse voltammetry. And I just want to kind of reassure you that in the software, last week we were talking about cyclovoltammetry quite a bit. And I'm trying to remember if in the paper that Hasim did on MIPS, whether he used, I think he might have even used differential pulse voltammetry there. But anyway, differential pulse voltammetry is easily selected as a methodology. So we've taken the electrode that's been functionalized with the antibody. We've tested it without the presence of protein, and we get a signal. And so what happens is, and if you read the paper, we get we get a signal here at a at zero concentration. Then we add in HCG, the protein of interest, and we remeasure it, and we get a new peak. But it's the magnitude of the peak is slightly higher. That basically, this is a negative current, but the magnitude is greater. So we get at zero, we get one signal. At, let's say, one binding event, we get another signal. Then we bind again, we add in some more protein, and then we do the differential pulse. We get a new peak. We can plot that. Then we add in the, let's say, the final increase in protein. And there we are. And Hasim says that in his paper, he uses differential pulse voltammetry, which is quite useful because those guys of you who are in Indonesia, Hasim does have an anapot, and he has used differential pulse voltammetry himself. So finally, what I should have said is that finally, then we add in the last amount of protein, and we get the peak. So I've kind of given two slides. First of all, the first slide was this is how you form the sensor, and then the second slide is how you test the sensor. And I do like the way Hasim tested his molecular imprinted polymer last week using differential pulse voltammetry. And this week, we're talking about protein detection, and it's the same theme. It's differential pulse voltammetry. So I really feel like electrochemistry is this kind of toolbox, which has so many applications. But once you get into it, and you end up recycling, the same skills. So I did appreciate Hasim's comments about nice illustration. If you like these animations and the way we try to explain things, just let me know, because I do want to kind of one of the motivations of Zimmer and Peacock is we want everyone eventually to become an entrepreneur and get to market with a sensor. And one of the first steps in doing that is to make sure that we've conveyed the technical information to everyone so that they can actually start working on their own ideas. So I hope that the sincere way that we try to present and explain is working. So I will say, yeah, so what we've done then is we've added in the protein, and as we did it, the signal increased, and then we were able to use the peak height versus concentration to get a signal. And if you do read the original paper, you'll see that is exactly what we did, and we got a really nice signal in this paper. So I appreciate now it's in London now it's 18:19. We do like to wrap these things up, within the 30 minutes. I don't want it to be arduous for you guys. I do appreciate that. You guys come on every week. You do listen. And yeah, thank you for the thank you, Apra, for the clear for the feedback that it was clear. So let me just summarize that then. So there is a ZP Developer Zone. You are the members of the ZP Developer Zone. The ZP Developer Zone, has sponsored, has seemed to be able to talk at his conference. We're also very willing to kind of help in the writing of grant applications. So ABRA will lead a grant application, but DP will try and support him on that. Asim says, don't forget to take some coffee. Yeah, thank you. You're right. You're fine. And, you know, I appreciate, as much as you guys give to us, I want to give back as well in terms of, you know, making sure that it's a true collaboration. So we did sponsor Hasim. And I also, obviously this week now, we've talked about the detection of proteins. And I suppose I want to, when we first started the ZP Developers Zone, we were very responsive to answering the questions that you guys had. Now, and at the moment, you know, if you've got specific things that you want us to deal with, then we definitely will. I will try to, you know, kind of, yeah, I mean, I'm quite happy to develop the content, but if you guys got something specific, let me know on the Discord server or talk to his team. But otherwise, you know, I'm quite happy to, you know, carry on producing this content and speaking every week. But like I say, if there's something that you want to cover, let me know. I think I'm going to be pursuing this Bill and Melinda Gates program with APRO, because I do see that as a very interesting case study. Because if we can be successful on that, then I think we can actually use that as a model to help and to work with many more of you like that. So let me just say thank you for this week. Hasim has offered to, look, if you guys got any questions regarding electrochemistry, differential pulse photometry, and a pot screen printed electrodes, molecular imprinted polymers, let Hasim know. Hasim knows that you can get hold of me anytime anyway, so we chat quite a bit. Yeah, and also you know, Hasim was just saying that, you know, obviously with APRA, we actually did quite a bit of work on artificial intelligence. So, you know, what happened in that one, which we kind of, APRA took a whole series of photographs, and APRA labeled those photographs up as being positive and negative, and then ZP was able to create a AI algorithm to actually then distinguish the positive and negatives using a computer. And hopefully APRA and us, we can actually tie that into a grant application to the Bill and Melinda Gates Foundation. So, yeah. And I'm just making a note here. Yeah, so next week we're going to do a talk on biosensors based on DNA or a particular gene. So next week it's going to be a similar talk, but we're going to do it on DNA and gene detection using electrochemical sensors. So thank you, Avril. That's next week's topic. Right, I've said enough. I do appreciate it. Thank you for coming up with a topic for next week. So next week we're going to talk about DNA detection. In the meantime, thank you very much. I do appreciate it. Hasim and Avril and Dima, appreciate you guys making the comments online, and speak next week. All right, take care, guys, and have a good weekend when we finally get to the weekend as well.